Hello everyone, welcome back. So we are going to deploy HashiCorp Vault on AWS EKS Fargate. This setup lets you run Vault without managing EC2 worker node because EKS Fargate contains container which is running in a serverless mode. So what is the advantage of this? That is we don't need to patch anything in EC2 instance. We don't need to do any scaling like many companies use scaling other third party tool to scale up and down, and we don't have EC2 billings also. Why? Because we only pay for the CPU and compute memory which we use for the pod level. So what is Kubernetes EKS cluster means? This will be fully managed serverless EKS cluster by the AWS itself. So in this, let's deploy HashiCorp Vault. So many will be knowing what is HashiCorp, and HashiCorp has released a vault where it acts as a secrets manager. Here, what we can do is by using this HashiCorp Vault, we can achieve a cloud native because we can deploy this HashiCorp Vault in any cloud, whether it is AWS, Azure, or EKS or GKE. Sorry. So what does the Vault does is Vault is a secret manager tool by HashiCorp. You can store tokens, passwords, API keys, certificates, encrypting application data, everything which you can store. Everything can be stored here. This is my Git repo link where you can check out. I have given the step-by-step procedure to deploy HashiCorp Vault. So let's get started. So initially, what you have to do is, as already said, like after creating AWS account, today what we are going to do is, instead of creating manually, we are going to use AWS CLI command. For especially EKS, we have a CLI command class EKCTL, especially to create resources in Elastic Kubernetes. This is what we have used here. If you see here, I have already installed EKCTL in my local. So we are going to create an EKS cluster, and then we are going to create a Fargate profile in it. So first command to create EKS cluster is EKCTL create cluster, and we will be giving a name of the cluster as Vault Fargate demo, and then we'll be choosing a region called AP Southern, which is nothing but Mumbai, and we will be explicitly mentioning this is for Fargate, so we are mentioning as Fargate. So open your terminal and configure AWS CLI. Also give the credentials and use access keys to you should be an admin access. You should have an admin access to create these resources. This will create all the resources. The advantage of EKCTL is nothing but if you want to create or provision a resource, whether using Terraform or whether using a manual method where we go use an UI and manually go in and create, we have to create an each resource. For EKS, we have to provision VPC, then we have to provision subnet, public subnet, private subnet, and then we have to configure NAT, IGW, everything has to be configured, security group, route tables, everything we have to configure. But advantages of creating EKCTL is EKCTL not only creates the cluster, it also creates the required resources for it. Like at the time of creation, you can see. So there is no cluster, right? When you refresh, it will be starting creating a cluster. Parallelly, when you search for VPC, so AWS has a default VPC, but here to create this resource EKS cluster, it will also provision the required VPC with every subnet, route table, everything will be configured automatically. Go inside the VPC, you can see EKS Vault Fargate demo cluster. This is the cluster name which we have given. So it is automatically creating VPC for us. If you go inside and see, so it is having public and private subnets in multi availability. See, like we have in 1A, 1C, and 1B. And also it has automatically created route tables for us. Not only this, it would have created NAT also. Like it has attached internet gateway and NAT gateway also. So it will take some time to create resources, as the first VPC will be created, subnet will be created, then inside it the EKS cluster will be deployed. We have to wait for some time. Like we can monitor here. So it is using CloudFormation in backend. Even though we are using AWS CLI and EKCTL, it will be using CloudFormation stack to create all the resources. So let's wait for some time to create the resources initially, and then we go step by step as per our documentation. Let's read the console output. You can see EKS cluster version is this, and it is referring to our AWS AP South one, and then it is creating. It is choosing availability as AP 1B, 1A, and 1C. Then it is creating subnets in each availability zone. Then we can even give the cluster. Here it is automatically taking as 1.30. We can provision this here also. Either we can give this ekctl command, or else what we can do is we can write a YAML file with ekctl commands in it, and we can run the YAML file just like we deploy Kubernetes deployments. And then when it is created, then CloudFormation is picking up and it is started to create the required cluster with the given name. And once it created the cluster, it is adding add-on, like it will be adding core DNS, VPC CNI, and PVC things. If we need additional add-ons, we can add using the same commands itself. And once it successfully created each resources, and then it is creating Fargate profile. This is what differentiates EKS Fargate and normal EKS. We are additionally creating a Fargate profile so that it will run as a serverless, and when we deploy an pod, automatically generally when we provision EKS, it will create we give the additional node for running the tasks. Here what it does is automatically it takes automatically when we deploy any deployments, automatically it will be provisioned in an isolated isolated EC2 instance, which is handled by AWS itself. We don't manage anything. If we want to deploy a faster deployment, but we don't need an managing headache, then we can choose EKS Fargate for dev and testing environments. It has created Core DNS, and then we can see this EKS cluster has been ready. Once it is ready, we can do the next steps. Once it has been created, cluster has been created, you can either update if you are using a previous version. As AWS mentioned, this is not required, as we can check by get nodes. Yes, see, Fargate is there. Previously in EKS cluster 2 years before, we have to update the config file so that we can access the cluster itself. But now that that has been deprecated, we can easily get this. After that, as we are going to deploy, let's create a namespace called vault. We're going to create a namespace called vault. The command is like kubectl create namespace space vault, the name of the namespace. Once you create, it will show like has been created. We can list this like get ns, which is namespace slash capital A. It will list all the namespaces which we have created. So we have default namespace, cube node release, and view public and cube system, and this is what which we have created. Okay, then what we're going to do is next, as it has created a default profile, if you can see, create Fargate profile FD default on EKS cluster, but we require a specialized profile as we are going to deploy this. So for that, I am additionally creating an additional profile. So the command is same, like it is will be creating Fargate profile, cluster name which we have already created. We have to give the same name, and the name will be vault profile, and the namespace is our namespace which we have created above. Let's create the Fargate profile and wait for some time. Just like that, which we have already done above, it will take some time. Let's wait for that. If you can see, it has created the profile which we required. Next thing is the cluster is up and running. Now we have to create an YAML file. So for the YAML file also, I have documented. So how we are going to deploy this Kubernetes, sorry, a vault is like we will be using only two file. We are not going to install with Helm charts. Helm charts are not supported here. What we are going to do is we will be writing deployment and service file in a single file, where we'll be putting replicas, everything, every details. As you can get this everywhere in every documentation. We will be focusing more on EKS Fargate and less on Vault. But what I just want to tell is, like, in service file, we are giving cluster IP itself, as we don't need a load balancer for this hands-on. But in production, what you have to do is we have to change this to load balancer type, so that it can accessible from the load balancer in public. So I have already created this file. Env I have to configure. I have configured this password as root token demo. You can copy this YAML and using Vim you can create. I have already created a file cd ult. I have created a folder called vault. In that, if I do ls, I have already created YAML file hands-on.yaml, which contains this YAML script. You can just copy paste or understand. It is very simple. We are using the HashiCorp image. The version is 1.21. Like, how do you apply this? It is simple. Like kubernetes command kubectl apply -f our file name. Just copy them. So let's wait for some time. Let's deploy. So deployment has been successful, as it is showing like it has been created and service is also created. So let's check them. K get deployment -n namespace vault. Yes, it is not still ready. K get pods. Let's see pods. UDS. Okay, get pods in the namespace. So it is still in running state. And similarly, we can get K get SVC, which tells the service which we have deployed. Namespace is vault. So this is cluster IP. Either you can use cluster IP, as this is a basic hands-on which I want to show you. I am using cluster IP so that we don't incur a cost. If this is for production, then you can use this type as load balancer. By with the load balancer URL, we can directly use them. Let's check the pod. Okay, get pod. Yes, now it is running. So to look inside how it has been configured, let's check the log. Klogs, the pod name, which we have to copy. Pod name -n vault vault, it will give the logs of this vault. So as it mentioned, to expose this we have to export this variable. Okay, before doing that, we have to access this vault, right? As we have used cluster IP, we are going to port forward. How do you port forward? Either you can port forward directly to the pod, or basically how we do port forward for testing is we direct to the service itself. So service name is vault. So /service/vault means automatically port forward to the respective service. kubectl port forwarding -n svc / the name of the service, which is vault. So we are going to port forward this. Once we port forward, it is getting forwarded. Parallelly, what we have to do is we have to open another shell, and as per logs, it is asking us to export the value so that our port forwarding works. Okay. So once you do this, go to the browser which you are using. Here what we can do is let us type local. Before this hands-on, I have already documented it. So that's why I'm getting this post A200. I have already done this hands-on, and then I am recording this again. That's why it is populating up. So you have to put the local host along with the IP address. Once you do that, this is how you access the vault. The console will be looking something like this. We have a token. As this is the main console, we can go by token, as this is the first time we are logging inside the vault. Go to the document, go to the logs where you can see the password. See, the unsealed key is here and the root token is this. So we have to give this token. This token is coming from our variable file, that deployment file, where we have configured environment variable as root token /demo, which you can see here. That is what it is getting injected inside the pod. Go inside the vault and give the token. This is how you go in. So this is the fresh console where we have deployed the vault, but this is dev vault. You can make it production. Here we have not provisioned PV and PVC. How we are accessing it temporarily is using empty dir. It will lose the state of the file, but when it going to production, what you have to do is you can provision PV and add it to your YAML file. So how do you create a secret here? Go to secrets engine. You find us enable engine. You have lots of things which you can we can explore this later. We give accesses for other persons and we can write policies. It is another version of AWS secrets manager. But when we choose AWS secrets manager, we can only use secrets within AWS. But when we go for cloud native vault, we can use in all the cloud environments. It is compatible with all the environments like Azure, GCP, Oracle, and AWS, and lot more. Go inside secrets, create a secret. Let's say while configuring config management and secrets, many companies use external secrets. Let's say this is an external secret. They will be creating like key clock /sec or ECTS, or let's say this is RDS secret, prod /RDS/secrets. This is the path which we'll be giving in the YAML file for secret manager, and we'll be giving us RDS host dummy DUMMY This is how they create the secret. RDS host add RDS PSSWRD password, something like this. You can add anything, whether it can be API keys, passwords, every secret you can manage here. You wait me and save here. This is how you create a secret inside HashiCorp Vault, which is a cloud native solution for all the AWS services. Once you have done it, so we have to clear this resource, right? That is too much important. I have documented the same thing. Like it is very simple. Provisioning EKS using EKCTL is also easy, and deleting the resource is also easy. And another thing I want to show is, as we have port forwarded, it is coming here. So what if we stop that? So see, it is connection for 820. So let's say Control C is there. Now you won't be able to access it because we are just port forwarding it for local testing. That's why we need a load balancer. See, site can't be reached. You go again and port forward this. Once it start coming up, our application will be, see, it has been forwarded but not connected because we have to manually go and hit the UI so that this change will be reflected. Once you refresh this, what happens is again it will be populated like we have seen it before. If you go and check our, see, handling connection for 8200, okay, let's cancel this. The hands-on is over. Let me show you how to clean this resource. Once you have created the resource, by only single command you can delete them, like ekctl delete cluster, the name of the cluster name and the region. Once you give, automatically every resource which has created, like VPC and our subnets and EKS cluster add-ons, everything will be completely deleted. Similar like how it has created, it will delete one by one and we will get the results. The console output will be fed here. Thanks guys. See you later.